Objective 3, linear functions. This is a review, but nonetheless it's good to review it fairly quickly. We'll even add a simple problem that's useful in calculus. We're going to assume a function is linear. You'd have to know something about the function. There are plenty of instances where linear functions come about. Linear, think of this as coming from the word line. So linear functions are basically straight line functions. Suppose we know that f of 2 is 3 and f of 4 is 8. We want to find f of x equals mx plus b, and the slope of any perpendicular line. That's a very important coordinate geometry concept. Well, first of all, it's easier if we rewrite this f of 2 equals 3 in ordered pair notation. That really says x is 2, y is 3. And then we also have this point over here, f of 4 equals 8. And that really says we have the point 4, 8. That makes it a little bit easier. Now we can calculate the slope, y2 minus y1 over x2 minus x1. And you could do 8 minus 3 over 4 minus 2. And we get 5 halves. That tells us we have y equals 5 halves x plus the y-intercept. Then all we have to do is find b. Well, you can use 2, 3, or 4, 8. Take your pick. You can flip a coin, whichever one you want. But we have xy is equal to 2, 3. So x is 2, y is 3. We can substitute 3 here. Equals 5 halves times 2 plus b. And cancel out the 2's. We have 3 is 5 plus b. And so we have b equals negative 2. And so we can substitute negative 2 back in. Y equals 5 halves x minus 2. And of course, if we can use the f of x notation, f of x equals 5 halves x minus 2. And that's our first answer. Second of all, we want the slope of any perpendicular line. And if the slope is equal to 5 halves, and perpendicular is a negative reciprocal, so it's just negative 2/5. As simple as that. That's the first method. Now let me show you a second method while we're on the topic. Each one works equally as well. Instead, we could have said y minus y1 equals m, x minus x1. Now we already have the slope, 5 halves. So that's going to go right here. And then we can let x1, y1 be 2, 3, for instance. And that means 3 is y1, that's got to go right here, and 2 has to go right here. And so that gives us y minus 3 equals 5 halves x minus 2. And that's the same equation. Of course, it's not in simplified form. Y minus 3 is equal to 5 halves x minus 5 halves times 2 is 5. Then, of course, we can add 3, and we get y equals 5 halves x minus 2, which is the same as the first result. So this can be derived very simply from the slope formula. M is equal to y minus y1 over x minus x1. And we just leave a variable here. Any point on the line has to satisfy the slope formula. That's the basic way to derive it. We have a point and a line. Well, you can pick any point, and guess what? From here to here, we have to have that same slope. You can use that to generate the line. So, and of course, you can finish this up, f of x equals 5 halves x minus 2, et cetera, et cetera. Now here's an interesting problem. Where do these two functions intersect? They have different slopes. We're in the plane, so they have to intersect somewhere. This is a valuable pre-calculus problem. In calculus, a fundamental question is find the area between two curves. And the first step in doing that is to find the points of intersection. So this is a valuable skill. We're not going to find the area in here, but this is a good precursor to calculus. Well, we can find out where f of x and g of x intersect. In this case, we have two straight lines of different slopes. When they intersect, the x values are equal and the y values are equal. So we're going to solve the problem by setting this y equal to this y. And we set 2x plus 5 equal negative 3x plus 10. Move the 3x over here. Okay, you can situate the algebra however you want. Move the 5 over here. 5x equals 10 minus 5. 5x equals 5. X equals 1. Well, given that x equals 1, you can substitute in here. Let me erase my intersecting lines there. You can calculate f of 1 is 2 times 1 plus 5, or 7. And of course, you can calculate g of 1, and you get negative 3 times 1 plus 10, which is also equal to 7. It's a good thing they're equal. If these were unequal, we would have made a mistake back here somewhere. And so the point is 1, 7. Okay, that concludes this section. Fairly short, but a review. We don't spend a lot of time on linear functions because we have so much more important information in this course. We'll be back with quadratic functions.